माइक का पोजीशन ये बेस्ट है कि अभी कुछ अच्छा यहाँ तो आउटपुट हमें नहीं देगा ना, यहाँ पता नहीं चलेगा कैसे। अभी सभी म्यूट है, हमारा साउंड जा रहा है। बोर्ड का क्या है? तो करेंगे नहीं सुटेबिलिटी। अच्छा कैमरा मूवमेंट आपको चक्कर है।
Not visible, sir. Camera angle not appropriate.
So good afternoon everybody. This time in ICT based courses, basically human touch is always a issue. So I'm hopeful that you all are attending. Loaded with a good food, and usually it's difficult even especially in a summer afternoon. So today we will discuss something interesting, and I will try to make it further interesting. So we are going to discuss today about ZigBee. ZigBee is basically a standard which has been targeted for low rate wireless personal area network application type of applications. Basically the genesis of ZigBee is into
SCS VM University. And others? Hello.
Tell me, sir.
प्लीज माइक ऑफ रखें, माइक आपकी डिस्ट्रीब्यूशन बहुत है, माइक ऑफ रखें प्लीज.
So before going into exactly what is ZigBee, and I think some introduction has been given about ZigBee in the morning also. I want to basically discuss about the OSI model. I think we all are computer science students are well aware with the OSI model. So that is basically a standard or reference model which is inculcated into most of the communication protocols in the field of computer science we encountered. And within that you need certain protocols and certain interfaces. Naturally, you are all aware, I think, that what is protocol and what is an interface. To sum up, protocol is basically the rules and regulations which define the communication protocol standards between two identities of equal stature. That is protocol. For example, if you want logical communication between end-to-end network layer or session layer, then it is through protocols. And on the other part, the rules and regulations which define communication between unequal entities, that we call interface. When the network layer communicates with the data link layer, or data link layer communicates with the physical layer. So in a setup, basically the physical communication takes place through interfaces, and while the logical communication takes place through the protocols. In that sense, how it is executed is mostly through the packets, and packets of each and every layer, which is loaded by the layer with its headers, and these headers along with these headers for the lower interface layer, that becomes a new packet. And in this way the physically packet moves from one end to another end. Whereas in case of the logical communication, or where protocols play a role, at the receiving end, the headers and the footers, whichever are added by a particular layer, are separated, they are read into, their meaning is analyzed, and a particular action is taken. So this is basically how the communication takes place. Now, depending on the nitty-gritties of the communication, requirements of the communication, requirements of that protocol, the number of layers can be 7. Ideally, they can be merged, they can be overlapping. So in that sense, it is a reference model. Like in mythology, you have Bhagwan Ram. He is a reference point of human life. So similarly, you have a OSI reference model. Now, depending on the requirements or applications which are envisaged, various standards have come. At first, you need some hardware standard for a particular communication technology. So what happens in this world, or what happens in the world of standards, is at the initial level, at the hardware level, some organizations like IEEE or ITU, they play a role. They come up with a minimum hardware standard, or in other terms, technically we speak, they come up with the physical layer definition and the data layer definition for a particular communication technology. And you are well aware of 802.11, which is the genesis of your Wi-Fi. Then you have Bluetooth standard, which has roots in 802.15.1. These 802.15.1 or 15.2 or 802.1 L11 are all standards which has been proposed by IEEE. Over the time, what happens is, whenever a new hardware standard comes in with a focus towards a particular sector, for example, you are well aware Wi-Fi is meant for wireless LAN, whereas WiMAX is meant for wireless broadband, or MAN if we go into the technical roots of that thing. And similarly, there was a gap in the field of wireless PANs, personal area network, where you have a requirement of distance coverage to around a meter or something. However, Bluetooth has served those things also, but Bluetooth was basically a high data rate thing. You don't need such data rates for control type of applications. How many times in a day you switch on or switch off your tube light? Once or twice. So, but with Bluetooth radio, you need the power requirements, you need daily charging and all those. So it was more suitable for ad hoc networking type of solutions, or file transfer, data transfer, all those. So what happens in the industry is, whenever IEEE comes up with a particular standard for any field, mostly whatever technologies have come into commercialization, Wi-Fi, Bluetooth, WiMAX, in most of the cases, what industry did was, they come up with a non-profit organization. For example, in case of Wi-Fi, there was a Wi-Fi Alliance. In case of WiMAX, there is WiMAX org. In case of Bluetooth, there is Bluetooth SIG, Special Interest Group. It is nothing but a agglomeration of lot of companies which are working in the field of communication. Why do they do so? Because if you want to invest in a technology, it's a huge investment, and definitely you need a visibility of 20 to 30 years, unless and until you are not behemoth like IBM or for that matter Honeywell, that you can sustain your own things. But mostly what happens in the industry is that they come up with a group which works on that technology, proposes something for the upper layers beyond the data link layer up to somewhere up to sessions layer. They propose standards for those things, so that across the industry support is available when the technology matures. Secondly, you have confidence that lot of people are involved in it. So their functioning is basically like that. They have a board of governors type of thing. For example, Zigbee Alliance has a board of governors type of things. All the companies which are part of the Zigbee Alliance are member of that group. They work on that particular standard. They come up with the protocols and interfaces for the Zigbee technology. And naturally, there would be certain certification and testing components also. That when you put a Bluetooth logo on your product, that means your product should follow certain standards which are prescribed by the Bluetooth SIG. Similar is the case for Zigbee. Zigbee Alliance is the body which controls these things, and they propose a standards for that, and at the very same time provide the certification for that. Now today we will look into extensively what Zigbee is, what is the genesis of Zigbee, which is basically 802.15.4, and then the various stack layers of Zigbee and their functionalities, which you might feel sometimes to be redundant if you have read OSI model properly, but that is it. So we will look by that aspect, and then finally I will show you some examples, and finally how Zigbee aspires to change your life. For more information, there is zigbee.org website. Entire information is available on it. Plus the education kits also come for Zigbee. Zigbee controller based kits are there from Zenic or NXP. So if you put some NXP Zigbee tutorial, so there is one 6 module tutorial out there which will give you a good idea of how to implement the Zigbee technology. More or less, XB is also something which is based on 802.15.4. But naturally there are a lot of other protocols also. They might be more known, they might be less known. But Zigbee is something which is more into forefront. So this is how we will cover our talk. Introduction followed by an overview of 802.15.4. Then I will discuss the Zigbee architecture from the textual point of view, and followed by the Zigbee stack description. I have covered only up to Zigbee 2.0. Right now the standard is Zigbee 3.0. But basically Zigbee 3.0 and in between 2.0 there was Zigbee Pro. Zigbee 2.0 was followed by Zigbee Pro, and then we have Zigbee 3.0 right now. The basic since the Zigbee technology is right now not very progressful, it is in the research domain and developing domain. It's a good concept, but as far as Bluetooth is concerned, Bluetooth has become a business progress. So now if you say that Bluetooth is 802.15.1 compliant, that is not the case. But up till now Zigbee is 802.15.4 why not? If you want, I can give you the idea. Basically, you know that IEEE is a academic body, so they have academic interest. They doesn't want much fusion. So when they came up with Wi-Fi standard, that was meant for ad hoc network. When they came up with Bluetooth standard, that was meant for ad hoc file transfer type of application. But when Bluetooth became a commercial success, the Bluetooth radio was everywhere. So the Bluetooth SIG started trying to venture into both fields. And on one end, it ventured into the domain of Wi-Fi through high-speed protocols, which were not ratified by 802.15.1. So naturally, if you want a speed beyond a limit, you have to accommodate the radio, which is at the base. And if you change the radio without the ratification of IEEE, that won't be based on 802. Similarly, they have tried to venture into wireless PAN space also with Bluetooth low energy. And Bluetooth low energy is nothing but basically it was a effort by Nokia, if you heard about Vivri. It was one protocol called Vivri. So over the time, since Nokia failed commercially, Vivri has amalgamated into Bluetooth low energy. today what Bluetooth 4.0 you see is basically a merger of these three things: Bluetooth Classic as well as Bluetooth High Speed as well as Bluetooth Low Energy. But as of now, Zigbee is pure. It is meant for wireless PAN application. What 3.0 is proposing is, or what 3.0 is going into, is more with IP connectivity. That is more about IP connectivity, as well as up to 2.0 there were individual profiles, Zigbee profiles, which provided you specific solutions: home lighting profile, you have home automation profile, you have the store profile, that type of profile. Now with 3.0 there is switch off your mic, and if you have any question, then it's welcome. So like those language thing, then what happened over the time, those language merged, a base class library came on. Above that base class library you have individual libraries, and at the top you have programming environment. So similarly things move in these domains also. So Zigbee stack we will discuss 2.01, and 3.0 if you want, I have one note I will give you. And besides that, Zigbee 3.0, if you go through, more or less things you will find the same, but at the top they are more into interoperability within the profiles as well as interconnectivity with the IP, so that you can control things from your mobile and all those things. Recently you might have seen an ad in TV that husband and wife are fighting in the car for who goes to the home first. She says you go, she says you. That the motive is that they want whoever goes to the house first will start the AC and all other things, and then one of them automates it with the mobile. That's a Godrej products are coming. So they are not necessarily Zigbee product, but they are more or less based on 802.15. And finally we will discuss about the Zigbee applications. Whenever you have a question, please interact. So what is Zigbee? Basically the first line I have taken from the Zigbee org website. This is what they say from the commercial point of view, that Zigbee is the wireless language that everyday devices use to connect to one another. It is basically a wireless language that everyday devices use to connect to one another. As far as technically, it is an established set of specifications for low rate wireless personal area networks. It is a technological standard that has been created for control and sensor networks. We will see graphically where does Zigbee fit in our next slide. Zigbee is based on, as I have already told you, 802.15.4. 802.15 is the working group for wireless sensors. So within that, 15.4 is for 802 is LAN MAN Standards Committee, and 802.15 is Wireless Personal Area Network, and within that 0.4 is low rate WPAN, whereas 0.1 was Bluetooth. It has been created by Zigbee Alliance. So as I have told you the entire story, that how Zigbee Alliance comes into the picture. Now where individual vendors comes into picture is at the top of the stack. At the top of the application layer, individual product specific features are inculcated by the companies and they come up with the products. So which extends the upper layers of the stack not defined by 802.15.4. What is Zigbee Alliance? It is basically an independent, neutral, non-profit corporation established in 2002 for wireless standards, WSN standards development. Even we can become the members, not in the decision making role, but as a participating member. Anyone can join and participate. Over 400 companies worldwide are members. This data might be a bit old. Right now more companies are there, and the membership is global. Around 40% are from America, around 30% from Europe, and Asia also. Chinese are in showing up everywhere, whatever journals, and yes, they have captured the journals, they have captured everything. So the activities include basically, as I told you, this is not limited to just Zigbee Alliance. These three lines are meant for whatever you think: Bluetooth, WiMAX, Wi-Fi. They are involved in these three activities. That they develop open standards for wireless sensor and control. Here it is open. In case of Bluetooth, it is a patented standard. So whosoever is the member of the Bluetooth is given a friend license for that particular. The product certification and compliance programs. Naturally, if you want to have your product certified by Zigbee Alliance, and if you want to use a Zigbee logo on your product, there are two types of Zigbee logo product and Zigbee compliant product. So those cases are there. And then branding, market development, and user education. Naturally, user education is one thing for which Microsoft never checks, usually doesn't go for piracy things in colleges or students. So basically, Zigbee is a key enabler for IoT, Internet of Things. And what is IoT? I think you are all well aware. It's basically interconnection of web of things, so that they can communicate on their own. They can generate useful and meaningful data on which you can perform big data analytics, and at the top you can have recommendation things and all those. This is how Zigbee wishes or wish to enable the Internet of Things through Zigbee smart homes. Then you have digital smart city concepts, wherein the entire metering platform there. Kindly switch off your mic. Okay. Then m-commerce services, or they also envisage, and then through the mobile terminal, through VoIP and other protocols, they want to integrate these things into a overall ecosystem for the Zigbee system. These are some of the members of the Zigbee Alliance. More members are there, but prominent ones are Philips, Mitsubishi. They are also there on the Bluetooth SIG. Now, first of all, how the name Zigbee came in? So basically, the reliance of Zigbee is on mesh networking, and the way a honeybee zigzags around a flower into a particular discharging or anything like pattern, on that basis Zigbee is named. So zigzagging pattern in which bees flies between flowers. Our Bluetooth is not, on the other hand, has nothing to do with the Bluetooth. It is basically blunt-end, you might have heard about. So it symbolizes the communication between nodes in a mesh network. And the network components, as you are aware that in a beehive, what are the network components? In a beehive, you have a queen bee, then you have drones who are basically supervisor bees, and there are worker bees who are responsible for collecting the nectar from the flowers. So similarly, in Zigbee also, you have three types of nodes. There are end nodes, there are router nodes, there are coordinator nodes. We will see that analogy. So now the question naturally arises is that since there are a lot of standards, why do we need another standard for wireless personal area? What are the requirements for that? Naturally, if we think about that, one thing is that we need low data rate applications. Similarly, when the thing is low data rate, we want to decrease. We want lesser power requirements, lesser memory requirements, lesser device cost. So first one is our intention, or the designer's intentions was to reduce the power consumption vis-a-vis Bluetooth. For a device with Bluetooth radio, for your instance, your mobile device, you charge every day. But you will never want to charge your TV remote every day or your AC remote every day. So one thing is that. Then you want to automate your switches and your bulbs. Okay. Now we are habitual of buying a bulb for 10 rupees. Then we bought CFLs for around 100 rupees. And then we are buying LED bulbs for around 150 rupees and we want to reduce it. Naturally, if we want a sensor system to be embedded in these type of things, you want the production cost of the radio or the sensor system to be very low, at least the end node. And then the development cost should also be low. So these are the things which you want to decrease. And finally, the bit error rate, the number of lost bits per number vis-a-vis the number of signals sent. So basically Zigbee technology relies on 802.15.4, which has excellent performance in low signal to noise ratio environments. So here you can see that in relation to other technologies like 802.15.1, which is basically we know as Bluetooth and other things, in low SNR environments, this 802.15.4 has good performance. Then, secondly, we want to increase sensitivity. For Zigbee, it's more sensitive than Bluetooth. Flexibility, since it supports mesh networking with a 64-bit address, naturally in a mesh you have around 65,536 devices, whereas in case of Bluetooth you are aware that there are piconets, and then you can have parked metric address of 8-bit, but then it is that device is not active. So in Bluetooth you have 7 in a star. And security aspect, the security, I am talking about Zigbee right now, so I will naturally say it has 2128 bit. I will talk about Bluetooth. Yes. Primarily this one, yeah. Then latency requirement. Please switch off your mic. It's quite disturbing. Do you have any question? So for the latency requirement, there are certain applications guaranteed attention after slot time. So for those purposes, there is a provision of guaranteed time. We will study within the wake up time that heard of. Otherwise, you have CSMACA with collision. The range also issue in Zigbee 75 meters in LOS. Otherwise, I have a very good kit. I would have brought the XP1 I have. So routers also you can contact. Condition now this is subjective. Again, this is subjective. When I will talk about Bluetooth, I will give you the options which make Bluetooth more. So these are the various usage scenarios for Zigbee technology. Industrial and commercial spaces. For industrial, you have sensor control systems and all those things, pressure valves, temperature monitoring, then fire sensor systems. All those things can be integrated for industrial things. And again, similarly, commercial entities also, you can have a Zigbee coordinator with lot of associated sensors. Since you have flexibility of 65,000 sensors, everything can come into it. Bluetooth has FSHS only. Bluetooth support frequency hopping. Why not? Simultaneously, you can have one device to have a master in one piconet, and it can be slave in another piconet. In that case, it can be done. that we can discuss. Oh, Bluetooth button. So then consumer electronics is a good scope. Right now some products are coming with these type of features also. Not exactly Zigbee they might call, but LG refrigerators have that system that you can communicate things. Toys and games. These days usually toys used to be very cheap affair, but nowadays as you can see you have a lot of gyro based cars and all those things. So it is also, if you are able to keep that radio cost below $1, so then it if it contributes just 10 to 5% to the total product cost, then it can be included. PCs and peripherals, which Bluetooth is ruling right now. Personal health care. This is basically a global scenario. Our country, I don't think it will take a lot of time, but globally in countries like Japan, where you have attentive systems, so you can have motion sensors installed in your house and all those things, and then if there is no movement for a particular time, depending on a particular setting, a alarm is raised. Home or building automation, this is one of the most promising and currently which is commercially very much successful in Western countries. This particular application is there. You have advanced metering platforms which with wireless meters for water, energy, everything, and all. Just everything that you can imagine for wireless sensor nodes or in general short range communications is covered by Zigbee. Yes. Then you have repeaters and all those type of things. Through routers you have I will show you one example. There is one city in Scandinavia, Göteborg, that is called basically Zigbee city. Telecommunication, basically those Baltic nations, na, Scandinavia, Denmark, they have huge process. In fact, one king who integrated all those four nations. He came up with a single kingdom. That is why Bluetooth is named so. So those countries, the latest work is always implemented and they are very advanced. So Göteborg, there is one city. If you write the name, you search it on the internet, you will find that they have the entire metering platform on Zigbee network. So naturally you have repeaters which signal enhancers and all those things are there. So basically this is a typical Zigbee stack. You have at the bottom the physical layer and the medium access layers. Then at the top of it is the place where Zigbee Alliance comes into play. So the Zigbee Alliance comes up with the software, network security and application layers as well as brand management for the network layer as well as the security layer and the application programming interface at the top of it. And then the individual applications are developed by the, here what do I mean by customer is customer for Zigbee Alliance, the product manufacturers or vendors, all those type of entities. Now the physical layer as has been defined by IEEE 802.15.4 are into 3 frequency zones. In fact, certain new frequencies has been opened up in China in the ISM band. It's basically ISM band, industrial, scientific and medical band. It's free globally, but within this 2.4 gigahertz frequency is available globally. 2.4 gigahertz is available free of cost globally. In India, 915 is a very prized possession because our GSM works on 900 megahertz. But this is available in US. Around 4 to 5 channels are there in this particular band, and this 868 megahertz band is available in Europe. So there is one channel in 868 megahertz band, and since US generally all the telecom it has in 1800 megahertz band. So that 915 is available out there, and in India as well as globally 2.4 giga is available. Certain frequencies are available in other geographies. For China, I don't remember, there are other frequencies also which are available in ISM. So this physical layer and MAC layer were defined by 802.15.4. We will see a bit overview. It might feel redundant to you, but I think it's good to have. So when LAN-WAN Standards Committee thought of a wireless PAN standard, these were the prospective application scenarios in which they thought that they might find applications: home networking, automotive networks, industrial networks, interactive toys, and remote metering. These were the requirements placed before them. Thousands of sensors in a small space. So naturally you need a wireless solution. But the sensors are frequently standalone. So naturally they should not be more power hungry. And they are frequently isolated. So their range should be moderate, not very small. These were the challenges which were faced by the Standards Committee. This thing I have taken from the IEEE website only. So these are the general characteristics of 802.15.4. You have a data rate of 250 kbps per second in the 868 megahertz band. Then you have a data rate of 40 kbps in 915 megahertz band, and then you have the data rate of 20 kbps in 2.4 gigahertz. Initially, they didn't envisage mesh much. Their purpose, their basically design idea was star or peer-to-peer operation. Support for low latency devices. What do I mean by low latency devices? Which wakes up very fast. आराम से सो जाए और फटाफट अपना जाग भी जाए. Yes. Conserve energy plus sensor type of play. If there is fire, it should there should not be any delay. So fully handshake protocol for transfer reliability was also thought of. So there should be acknowledgement mechanism for communication. Low power consumption, and then finally you have the frequency bands of operation. You have 16 channels with a band gap of around 5 megahertz in 2.4 gigahertz band, 10 channels in 915 megahertz band with a band gap of 2 megahertz, and then you have one channel just in European 868 megahertz band. These two bands are not available in India. So effectively in India you have 16 channels. Now here I think we can go through fast. That there are two radio hardwares. One radio supports 815 or 915 megahertz. The other supports 2400 megahertz. Their functionality is basically whatever is the functionality of a physical layer in OSI model. There is some change. Modulation techniques also are there that we will discuss later. And then this I think I have already told you, 2 megahertz band gap, 10 channels, 5 megahertz band gap with a in the 2.4 gigahertz. You have a physical service data unit which is 0 to 127 octets. Then you have a physical header, start of packet delimiter, and a preamble. The purpose is basically to organize the data. So naturally this part is meant for the intermediate thing, that PSDU will be passed on to the upper layer. Basically PSDU will contain the MAC headers plus MAC data packet. What is MAC data packet? Something which has come with loaded with the network layer header at the all those things. Yes. So then you have the MAC layer. Naturally again MAC layer functionalities are as they are: channel acquisition, contention management, frame security, and they are hop to hop layers. Basically they just have the knowledge of the next nearest neighborhood is the network. These were the design drivers. I think we have discussed: extremely low cost, ease of implementation, reliable data transfer, short range operation, and low power. Then the Mac frames can be basically of four types. It can be a normal data frame. Then it can be a beacon frame in case of for communication when everyone goes to sleep after a particular operation. In the case even the coordinator is battery powered. So a beacon is generated whenever coordinator wakes up, and all the other network nodes are synchronized to it through beacon. And then there are certain periods for CSMA CA followed by a GTS mechanism. Then you have the acknowledgement frame to ensure reliability that I have received whatever you have sent. And then there are to establish the MAC layer, there are certain MAC command frames. Yes.
That layer, if I say that there's no need to point and keep sending the packet frame that we need to shunt two of the things like acknowledgement frame. I can design it.
Okay.
As reliability is not my concern. Why is reliability is not my concern? Because each node is sending the pic to them. I'm talking about the
You're getting redundant in that. Okay.
And they are capturing, every node is capturing their image and then they are sending it to the coordinator. That's it.
But in that case acknowledgement might not be there. At the end node, it's not necessary that they have a
Yes,
yeah.
That is what my point is.
Yes.
My point is just to conserve the energy.
Yes. Yes.
Right?
That yes.
Then is it visible that I can shut few?
Yes. Acknowledgement is always optional. It's optional.
How can I simulate it?
But naturally there would be
From my side.
okay.
How can you please suggest me how can I implement it to the simulating tools and I have to present my
Yes. Now the case is that naturally if I have 4 frame types, naturally to distinguish between them I should have dedicated 2 bits for that purpose. Okay. Now you don't want this mechanism, you don't use it, but if you want to at least you need 2 bits even if you have 3 options. You will mask the 4 options. Provided if you take just 2 options, either it's a data frame or it's a command frame. Okay. So that beacon mode communication won't be there. In that case you can reduce 1 bit, but that is only a benefit of 1 bit. Okay. Yeah, you can always reduce. You can yes, there is flexibility for that.
where do I get these options in the simulating tools? That is what exactly I want.
Okay, so that depends tool specific. We will discuss. Yes.
That is the thing I have in my mind.
So you want to reduce the overheads in communication.
I just need to compact my packet, right?
Okay.
So as to conserve my energy.
Okay.
And then to show off the results to the simulating tools.
Which simulator you are using? NS2 or what?
I have tried many of them, but I didn't get.
You can't find you. Okay. Actually, we will discuss afterwards. So these are some of the Mac frames. Maximum 127 bytes is the Mac protocol data unit (MSP). So this is basically the wireless space. You have in the data range of 0.1 to 1 Mbps, you have Bluetooth. Okay, but there was no protocol standard which satisfied the need of 0.01 to 0.1, not more than 100 kbps. So for that, Zigbee was, in fact, 802.15.4 was proposed. Zigbee is something which has come up on the top of it. This I think I have already discussed. Now what does Zigbee do? It's designed for wireless controls and sensors, operates in PAN. I think we can skip. Control of light, switches, thermostats, appliances, etc. architecture, the basic network characteristics. Naturally, you can have 65,000, more than 65,000 nodes in client nodes in a network. The important point is that it's optimized for time critical applications and power management. And it provides you with the full mesh networking support as well as support for tree and as well as star operation. You have three types of nodes basically here. Yes.
Its range is defined up to 75.
Yes, it's maximum in LOC condition. Line of sight, LOS, line of sight. In this room type of scenarios, you need to have routers or in between devices. I will give you the PPTs, no issue. So then as far as ZigBee is concerned, you have three types of nodes. First is the ZigBee coordinator, which is only one in the network. It initiates the network through ZDO. We will read about ZDO later on. Stores information about the network. All the devices communicate with the ZigBee coordinator either directly or through their parent routers. It provides you with the routing functionality within the network, and it acts as a bridge to other networks in case you are interfacing with IP through VoIP or IPv6 other. Yeah, ZigBee coordinator is basically something which is a resource rich part of the ZigBee network. It is only one in a particular network, and that communicates with either all the nodes or if it's a star type of operation, or through routers if it's a mesh or a tree.
In a network of suppose 100 GPU nodes,
Yes.
one coordinator was there. Can we reprogram that coordinator from that to some other node? Replacing that coordinator with some other node, replacing other node in the coordinator. Or it is having some special from feature.
As far as 802.15.4 is concerned, there are only two types of devices. One is the full function device and other is the reduced function device. As we will move on, you can see that ZigBee router is also FFD. It is also a full function device in terms of 802.15.4. But as far as ZigBee is concerned, there is only one coordinator. If it goes down, naturally that is a flaw part. No, that is not symmetric like Bluetooth. In Bluetooth, the master is symmetric.
Actually, if its point is if any node, like
Yeah.
ZigBee coordinator consumes its
Yes.
analysis,
In case of Bluetooth, master-slave relationship is symmetric. A master can be a slave can be a master, and that role can be reversed. But here, that role reversal is not because it is about IoT, no? It's more a standard type of way, or it won't change very frequently. As far as coordinator is concerned, there is only one. It will actually initiate that.
Coordinator is acting as a hub.
Yes. They all will be slaves or routers or no and nodes. Then at the second level, you have a ZigBee router. ZigBee router is also a full function device as far as 802.15.4 is concerned. But in ZigBee, they have a different role. They are slaves, or they are under the ZigBee coordinator. And then they again have the child addresses, which they can further distribute between the nodes which are connected to them. So these are basically optional components. You don't need to have necessarily a router. You can have all the devices connected directly to the coordinator. But to provide a structure to the network, again, efficiency point of view se bhi aap dekhega, if a particular router has all those end nodes which are meant for for example, sensing type of application. Then there are other end nodes which are meant for metering type of application. So structure wise also it's good to have routers in your overall. It routes between nodes, then it extends the network coverage. Okay. Because you can't have end nodes can't communicate between themselves. They can either communicate with the router or they can communicate with the coordinator directly. It manages the local address allocation and deallocation. You can have local binding tables. You can have binding tables at the coordinator itself. Naturally, it's always an optimization between, as you were saying, what is your application requirements. Okay, you can have a very powerful coordinator with very simple nodes. In that case, your coordinator may be costly, but your end nodes are very cheap. For example, in a mall type of a setup, you never want a sensor which is attached to the fabric to be very costly. However, you can have any server or any coordinator and the cost you can manage, but you want that your end sensor is very cheap. In case of warfare systems, there are a lot of other considerations also, which we can discuss. These days, there is one concept of border management is coming up. Government of India is working a lot on integrated border management concept. Border management, sensor fusion of multitude of sensors are fused into a single overall border management system, so that the intelligence is gathered in real time. Real time, yeah. Yes.
Sensor nodes in the battery area.
Mm-hmm.
Where the deployment cost is far bigger.
Mm-hmm.
Then we need to conserve, extend the network lifetime
So,
and we need to
so
conserve it
yes.
as much as possible.
Then you have ZigBee end devices. These are basically the end nodes or something which are stationed at the last part where data actually generates. These are cheapest of the device type. Their form is also very small. Communicates only with the coordinator, or they can communicate with the router also. And sensors would be deployed here. Now again we have various types of traffic. One, the data is periodic. Periodically the data comes in. Then for example, your watch, every 1 hour it shows you an hour. Then you have data is intermittent. Intermittent data is the case of fire sensors and all those type of things. When fire comes in, signal is generated. And then the data is repetitive. It is always generated a priori at a particular टाइम. 4 बजे उस सेंसर पे क्या टेम्परेचर था, 6 बजे क्या था, 8 बजे क्या था. इस तरह की जो एप्लीकेशंस हैं जहां आपको इस तरह का डेटा गैदर करना, IMD टाइप ऑफ एप्लीकेशंस है, वहां डेटा आपको रिपीटेटिव है. नेचुरली डिपेंडिंग ऑन दिस आपके जो ट्रैफिक मोड्स हैं वो भी डिफरेंट टाइप्स के हो सकते हैं. वन इज द बीकन मोड in which a beacon is sent periodically. Periodically, I communicate to you. After 5 minutes, I will tell this thing. Now, for 5 minutes, everyone can hibernate. Okay. So, in this case, the coordinator as well as the end device can go to sleep. In harsh environment, for example, for certain avalanche monitoring, you have set up a sensor system. So, naturally, there you don't have wired power. Even your coordinator is battery powered. So what they do is they will have some mechanism that after periodic time only everyone wakes up. In that case, synchronization is naturally important. The timing of each device is important, because if it is not that so, then it will happen that yes. But then clock integrity is an important aspect, na? Naturally, the energy consumption is lowest because even the coordinator consumes very less power, but the precise timing is needed, and then the beacon period is critical. This is a typical scenario of a beacon mode, wherein a network beacon comes in. There is a beacon extension period, so that if there is certain trade-off between the timing of various devices, that is also settled, followed by a CSMA CA period. There is a contention period. in these slots anyone can use the channel if it is available free. And then there is a GTS period wherein your devices which have a periodic data generation, they can submit their data. And then again with a beacon everyone goes to sleep. Second is the non-beacon mode. So here in non-beacon mode case, naturally you want your routers and you need to have, I don't say want, you need to have your routers and coordinator awake every time. Why? Because the data comes in intermittently. Whenever fire happens, only then it will. So you can't have any synchronization methodology. So for that case you need to have the coordinators which are awake every time. Coordinators or routers have to stay awake. So in that sense it becomes a heterogeneous network, that some are power hungry and some are power surplus things. And then the power distribution is asymmetric. The coordinator and routers have mains powered, and whereas your end nodes are battery powered or very feebly powered. Here again this acknowledgement is optional. Please go to the PPT. Here again, as you can see that the network device generates the data intermittently. Since the coordinator is awake all the time, it is able to receive it. And if your system is not so sensitive to volumes, you can have an optional acknowledgement. For example, in case of fire safety solutions, you don't need much acknowledgement sort of things. Now topology, I think why I put this slide. You are aware with mesh topology. What is the difference between mesh and tree? No.
It's not like that.
No, that is not the case in ZigBee also. End nodes can't communicate between themselves. End nodes can't communicate between themselves. End node can communicate only through the router. Here in that sense, the difference is in mesh, two routers at the same level, they can communicate. Same level in the hierarchy. You have a coordinator, you have 4 child routers of that coordinator, then again those child routers can have again child routers. So in case of mesh, two routers at the same hierarchy level can communicate between them. Rest of tree.
Basically, the speaker and the cord and what the length of the speaker. Basically, अरे त्याने कोणाला स्पीकरचा cord नाही स्पीकर
So in tree topology, as you can see that the ZigBee router at the same level are not able to communicate. PPT. Whereas in mesh, at the top you see those two routers. It is a very good visual example to understand what mesh is all about. Suppose this is the switch, and that light are connected by a radio, and whenever a signal is sent through this route, the bulb is switched on. Now, for instance, these two nodes die down, or these two middle path routers die down. Then, in that case, in case of mesh, it will automatically regenerate the path, and the signal will be transmitted to the source. Now, this is basically the stack of ZigBee. You have a physical radio, you have a MAC layer which we have discussed. Then you have SSP layer for the security functions. You have the network layer which performs the task of network organization, route discovery and message relaying. Then you have application support layer. This application support layer basically acts as an interface between the applications and the network. And then you see there is a Zigbee device object, which is spanning right from the application layer to the up to the network layer. So device management, device discovery, service discovery, these things are done at the level of. What is difference between device discovery and service discovery? There is a
slide change करने जाए
CV Raman College, can you hear us? CV Raman Engineering College, can you hear us?
कैमरा वाला देखा होता है अपन लेक्चर मैडम भी देखा था अपन लेक्चर
CV Raman Engineering College, can you hear us?
So this we can discuss. Service discovery is basically the type of service which is available with a particular device. So that all is done at the ZDO level. Here basically on each node you can have up to 256 applications. So each application which is running on the top of a node is assigned an endpoint address. In this vocabulary, that is called endpoint. Endpoint address 0 is for broadcast. Endpoint address 240 is assigned to the ZDO, and then 241 to 255 are reserved for future use. From 1 to 254 to 439 they can be assigned to any application which is running on a particular end. So at a time on a particular node you can have up to 240 running applications. Now basically we will see the hardware part, implementation part of Zigbee. So this is how the physically things move at the physical layer in the 2400 megahertz band. You have 4 bits per symbol. You have DSSS chips with 32 bits. Are you aware about DSSS? Direct spread spectrum. You convert 4 into 32. Then you have quad phase shift keying modulation, and then sine wave impulses are shown on the, and this is how things go on to medium. Similarly, for other bands there is 1 bit per symbol, so naturally data rate is lower. This I think we can skip. General error vector magnitude is less than 35%. Power minimum transmit power is 500 microwatt and all those things. Then I think we have discussed this at the 802.15.4 level. You can have slotted and unslotted CSMA CA. You can have beacon oblique non-beacon mode. You can define superframe structure. Then PAN management is done at this level also. Orphan drive, device realignment, synchronization, device association, disassociation, discovery, and all those things. Then another task which is handled by the MAC layer is transfer handling. Transaction based, transmission, reception, rejection, and retransmission, GTS management. So for granted time slot management, you need to have a allocation and deallocation, usage and reallocation. Another aspect is of frame security. Now, till now you have reached up to this level. That you have a coordinator and all, you have one hop distance nodes attached to it. Now what if you want to attach something to node 5? So you need some networking, and that is the task of network layer. So routing is done at the network layer. At the network layer, we have a distributed address assignment mechanism. I will skip pictorially, बहुत अच्छा समझ में आता है, वो मैं next slide में cover करूँगा. It can be tree structure or a self-managed by higher layers. 16-bit network space is divided among child routers. Child routers divide their space again for their children. So a router can also have child routers, so they can further divide that space between them. Now how you connect. These are the three metrics basically on the basis of which you decide that where you add a new node, incoming node you want to add. Maximum child count per parent, maximum child routers per parent, and then maximum network depth. A good example is, for example, you have all the 3S2. So now suppose then router 4 is connected to end nodes 5 and 6, है ना? So naturally maximum number of child it can have is filled. It cannot have any more child. So suppose another node approaches router 4 to get connected, it won't allow. Actually it will route it to. Network layer also performs the root cost estimation function. So root cost estimation is basically more all your word part and all those things you might have read. Weightage of the path as well as the signal strength, all those things. Those algorithms are there. I think Leach you were talking about. All those things are concerned, more discussed or elaborated in that part. Then route discovery. Route discovery is through AODV, ad hoc on demand vector algorithm. They follow. They send a route request package, and then the reply comes in, the shortest path from which reply is coming in, and those link quality estimation, all those things come into picture. So this is how routes are established. Tutorially it is very easy and fast to grasp. No? Then route maintenance is another part. Suppose a node goes down, so you have to orphan it out from the binding tables basically. And then whenever it is wake up again, you have to realign it. So track failed deliveries to neighbors. Naturally, always failures in this case is through failed deliveries. You will have something algorithm that you ignore it for 2 to 3 times, or depending on whatever is the flexibility in your system. And after a particular quanta, if the miss rate is more than that, you strike certain decision rule, and on that basis you take the decision. UDV is preferred in ZigBee, but there are a lot of algorithms for YSM because it's just ICE. Then you have the application support sublayer. Here you see that the application support sublayer acts as an interface between the application framework and the network layer, and this it does through service access points. SAP is what we call it. So each application will have a service access point. The ZigBee device object is assigned an endpoint address 0. Basically, it's an application address. They call it endpoint address. And within that also, then there are a lot of descriptors. If you go through that Xenic tutorial, these basics you will get very good. Means practical basics of what is node descriptor, then there is hardware descriptor, then there is power descriptor, then there is extended descriptors, which actually identify the application part of the ZigBee. And in fact, simulators will give you a better idea because there you actually generate that. So the application support layer, it acts as an interface to the network layer, performs the task of data transmission as well as binding and discovery. This we can skip out. Then at the application layer, you have an application framework. This framework basically specifies the data types. If you try to make an analogy with a programming language, for instance. So the framework, a programming language framework, for instance, framework of C, what it provides you? It provides you have to write a main with parentheses. You have certain data types. You can have instances of data types. Similarly, you have various data types. Then devices describe themselves with ZigBee descriptors. each device identifies itself, then only you can have connections. You can have connection types can again be one-to-one, switch and bulb. It can be one-to-many, switch and multiple bulbs. It can be many-to-one. For example, the light switches on the staircases usually. It can be switched off from the bottom one, and you can switch off from the. So, a Zigbee descriptor have these many information, like frequency band in which it can operate, its power description, up to what. Then application flags are there. You have application version, serial number, man. So now Zigbee device object is a very important application. It has an endpoint address 0. It is the one which defines the role of devices. Whenever a coordinator is started, it is the Zigbee device object which assigns the role of coordinator to it. And then whenever a new node comes in, whether it is a router or it is an end node, that is established out here. So it initializes the application support layer, network layer, and security service specification. It offers services like device / service discovery, binding, and security management. And then it assembles the information about the network for the Zigbee coordinator or Zigbee router. So in that sense, you have a Zigbee router, you have a Zigbee device object on the router also. Now you have two types of Zigbee products. If your application profile is such that it follows the Zigbee stack, and on the base of it Zigbee 802.15.4, then it is called a Zigbee compliant platform. For example, here this switch and display nodes, they have various clusters. You have multiple functionalities. This switch can have 4 functions. 0 is off, 1 is on, 2 is scene 1. For example, you have a single switch for this room and you enter here in the morning. It has a very good window fans with sunlight coming. So what you will want to, you don't want lighting much. If it's summer's morning, you want some cooling, some fans. If everything is Zigbee connected, then you can have a single scenario in which all these things will be controlled by that. Similarly, you can have a scene 2 for evening, and this group is called cluster. That terminology in that tutorial you will get very nicely. That terminology, it's a 6-module tutorial with a quiz at the end of every tutorial. So it is satisfying also a lot. And then if these application profiles are developed by individual manufacturers on the top of the Zigbee stack, which is again housed on the top of 802.15.4, such products are called Zigbee compliant products. Then in this case, the application profile would be manufacturer specific. He develops his own application. Now the Zigbee Alliance again comes up with lot of public profiles, which provides you the vertical slice through the entire stack. Means, for example, they provide you the advanced metering platform. That is a public profile. So that will give you all the controls and things you need for implementation of that type of environment. So if you are using an application public profile, then that product is called Zigbee logo product. So that is Zigbee compliant product and Zigbee logo product. 2 types of certification are provided by the Zigbee Alliance. Applications we have already discussed in the beginning, I think. Building automation. Within building automation, you can have high voltage AC control, advanced metering, lighting control, access control, all those things you can have a rate. Then personal health care, patient monitoring, fitness monitoring. I think I have pictures for all of them. This is a typical application example. You have a coordinator in the house which controls everything. Your light control, entertainment control, motion controllers, AC control, and all those things. And then you can have scenarios for that. In an industrial setting, again, you have environmental monitoring, you have high voltage monitoring, pressure monitoring, valve positioning, all those things, and they are controlled by coordinator. However, if coordinator fails, network collapses. That is a fact. Then within house also, you can have a base station, you can have a keyless entry, you can have range extenders, which you were talking about. If you have to implement for the entire city, you have range extenders, you have repeaters also. Then water shut off valves. If the water is filled, then it automatically shuts it off. Then there are water sensors, power sensors, attention sensors, reminder sensors. These are classes. You can have multiple type of sensor within that. Home entertainment is a very, right now in our house with IR remotes, we have how many remotes? AC, TV, set-top box. Yeah. So with Zigbee remotes, you can have a single remote for all those things. This I usually say is not meant for India, because if you go to any of the most reputed hospitals, you will find things, even Chandigarh also, although they work a lot, but still management is always a issue. So inpatient home monitoring is a distant dream. It can be possible in near future. So patient receive better care at reduced cost with more freedom and comfort. Patient can remain in their home, monitor vital statistics and send via internet. For example, there can be sensors deployed which take your blood sample, analyze it automatically, and then they pass on to the coordinator, and which is through IP, they are communicated to the, yes, all those, yeah, everything. And then you can have motion sensors. If elderly are living single or alone, then if the it can also generate an alarm. Commercial lighting control is a very good application. Why? Because in India, daylight timings change. So you can see in that bridge months, you find street light, either they are off till late evening, or they are on up to a lot of. That is why, because the times are fixed manually, and that operator does not, or usually do not adjust in the initial days. Now the ease with this is that you don't need direct power hazard at the switch point. That is one big, you don't need power there. The switch is independent, it's a radio module. You only need power connection at the power light level, or wherever it is actually required. So it makes things lot safe. That is also a point. Secondly, installation is easy. Design, installation, commissioning is very easy. Operation easy and intuitive to use, facilitating improved worker productivity. Management is naturally easy. High voltage AC is already wireless, I think, in the hospitals through keys and all those mechanisms they have. It can also be done through Zigbee. Advanced metering platform with Zigbee. This I will give you the practical example. This one city called Göteborg in Scandinavia. It's called the Zigbee city. This particular city has around 2,55,000 meters for electricity. There are 8,000 concentrators, around 17 repeaters, and there are 3,000 GRPS meters. And this is how the entire city is connected through Zigbee. And every house has wireless electrical meters and water meters. And this picture is very looks good now. This is how the Zigbee aspires to change your life. The moment, even now they are working on that, you don't need even to at your gate. You can be in your car, at your office, through IPU, you can manage. So meet and greet, sensible sensors, climate control, safer space with sensors like fire safety and all those things. No hassle lighting. You can have all those settings as per your convenience. However, in a house of 4 even, it's never possible to have a single setting. No? Even TV you see, you want to see the news, your kid wants to see cartoon channel, your wife wants to see soap operas. So it's very difficult, but still it can be thought of that you have 4 scenarios, out of which one scenario would be rarely used.
Sir,
Yes.
sir, if you want to control a home using Zigbee, how many Zigbees?
Pardon?
How many Zigbees enough to control a smart home or something?
How many Zigbee
Devices is need? It's a counter.
actually Zigbee devices are radio devices. Okay, so as I have told you that on a single radio you can have up to 240 applications. That means that you can have up to 240 sensors installed on a single Zigbee node. So how many is basically a subjective question. The case is that the network will be built as per your requirements. What do you need? So that depends, that will definitely decide the number. For example, in your house you need only water metering with Zigbee. So you have a single sensor which communicates with. In case of a smart city type of application, you don't need to have coordinator at your house. The coordinator or concentrator will be somewhere in the locality, which will collect the data from all the houses in the, or all the meters from the locality. I think I have answered your question.
Yes, sir. Yes.
So any more questions? So these are the various references. Right now Zigbee 3.0 is in picture. And
Hello, sir.
yes.
What is the latest standard?
Hello from TTC Jodhpur.
Zigbee 3.0 is the latest standard, but as I have told you that it is basically built around Zigbee Pro or Zigbee 1.0, but the additions have been regarding security aspects, regarding its interconnectivity with the internet protocol, so that it can be managed through your laptop, mobile, and all those other type of devices. But the basic genesis or basic functionality which you can think of about Zigbee, I have already mostly covered. Zigbee 3.0 is right now there. Yes, I've copied it here. Even if you want, they can send you, or I will send you. Give me your email ID. Yes, sir. I was hearing something from Jodhpur.
Yes, sir. Thank you for this excellent presentation, and we will require the slides.
Yeah, you please send me an email. I think I have displayed my email ID, sandeeps@csio.res.in.
Okay, sir.
So you mail me, I will send you.
Okay, sir.
Thank you. Any more questions, please?
Thank you, sir.
Okay. Truba College connected? Any questions?
For any programming, or any tool writing a program to control Zigbee.
Pardon, please repeat.
Tools you are using for Zigbee programming and what tools?
Okay, you have a Zigbee library tool chain which is freely downloadable. So you have that plus for simulation type of or actual hardware applications, you can have certain kits from NXP. EKT 5168 is the number, I think. That kit has around 2 routers, 4 nodes with even VoIP connectivity right now.
Can you
And
please repeat the name of kit? NXP from Philips?
NXP Zigbee kit, if you text in the Google now, you will get that.
Where to download the software tools, the simulator, the library header files, C language?
You type Zigbee toolchain at Zenic. And even I would suggest you that you should go for Zigbee tutorial at Zenic also. That is a very good tutorial available online.
Can you please spell Xenix?
JENNIC.
Excellent presentation, sir. Thank you very much.
Thank you. Thank you. So thank you everyone. My email ID is sandeep@csio.res.in. If you want the presentation